And as we discussed earlier, for kerosene, that's around about 220 degrees centigrade. Now, all I'm doing is heating up some steel so it's glowing red hot, and then I just add a small amount of kerosene to it. And you can see very quickly that kerosene heats up to its auto ignition temperature. And essentially what's happening is the kerosene is heating up. It's producing these flammable vapors, which are the same ones that we see in our flash point and flame point, but then the kerosene can be heated further beyond that point until such a stage that the flammable vapors can simply catch on fire just because of the actual heat that they're being exposed to. So there is no piloted ignition, it's just they're simply reaching such a heat where there is enough for that chemical reaction to allow the fire to simply come into being. Now the same thing can be applied to solid fuels. And you can see here that I've positioned a piece of chipboard onto our very hot piece of steel, and it quickly begins to heat up and pyrolyze. And as it continues to heat, these gases are getting hotter and hotter until they reach their auto-ignition temperature, at which point we have a flammable atmosphere because we have our pyrolysis gases and we have the oxygen from the air around it, and once we have enough heat, then the fire can come into being, which is what we know as an auto-ignition temperature. And it's essentially just combining the three sides of our fire triangle, being heat, fuel and oxygen, to get our chemical reaction. Now for a really good example of our solid fuels going through the stages of starting to pyrolyze and then reaching an auto-ignition temperature, we can actually look at structure fires. And I've covered some of this when we were talking about flashover, because essentially that's what's happening inside a structure fire. We can see here we have a fire burning on the left-hand side of the screen, and we have our couch on the right-hand side, and slowly but surely that couch is being exposed to more and more heat, and it begins to break down. Now we know that that process is the pyrolysis process, and that's going to start to emit more and more flammable vapors as it breaks down further and further. But as it breaks down, it's also getting hotter and hotter, which means it's getting closer to its auto-ignition temperature. And finally, if it reaches that auto-ignition temperature, what we'll see is that couch will simply burst into flames, even though there hasn't been a piloted ignition from the initial fire burning on the left-hand side of the screen. And there we go, we've seen that the couch has finally reached its auto-ignition temperature. And in fact, almost the entire couch was engulfed in flames within a split second. And this is because the entire couch was actually pyrolyzing and releasing these flammable vapors. So it only took a small part of the couch to reach its auto-ignition temperature for then the rest of the couch to be ignited. It was just waiting for that final heat source to ignite the rest of the flammable vapors.